in example 5, we were given the graph of a function, and we want to make a sketch of an antiderivative for that function. Okay, so let's say that we call this function f of x. So since f is an antiderivative of this function, then by definition f of x is equal to the derivative of that antiderivative. So this is capital F prime. All right, now, so the graph we want to sketch is capital F of x, the graph of capital F of x. And so what we can see here is that, therefore, on this interval, this portion here, we see that capital F prime is greater than 0, and from -5 to 0, capital F prime is less than 0. From 0 to 2, capital F prime is greater than 0. Oops. And then from 2 to infinity, capital F prime is now less than 0. Also, at these points, this point, oops, and this point, capital F prime will equal 0. So you can see that capital F prime is greater than 0 and then less than 0. So we can see that capital F will be increasing from -infinity to -5, and then decreasing from -5 to 0. So in other words, at -5, we're going to have a local maximum because f is increasing, and then after -5 it's decreasing. So we were given the initial condition that f of 0 is 3. So let's go ahead and just make sure we have that point. At -5, we're going to have a local max. So at -5, let's say, I don't know, maybe right about here. That's going to be our local max. And so f is increasing to that point. Okay. And then decreasing afterwards. Now another thing that we can point out is right here. Since this is the graph of f prime, at this point, this is where f double prime will equal 0, right? And same thing for this point right here. This is where f double prime is going to equal 0. And so what we can use that for is to for concavity and maybe even inflection points. Let's see if we can think through this. So on this part of the graph, this is the graph of f prime. So we said that f prime is decreasing, and then afterwards f prime is increasing. So recall that we said that if f prime is decreasing, it's going to be concave down, and if f prime is increasing, it's going to be concave up. So there is an inflection point because the concavity changes here from concave down to concave up. So at that would be -3. So at -3, there will be a change in concavity. So let's say like right about here. So from from -infinity all the way to -3, it's concave down. And then right after -3, now it's going to be, right after -3, the graph will be concave up. So you see how that change in curvature here. So here it's concave down, and now here it's concave up. Okay, and then at 0 we have our local min, because here capital F prime is negative, and then afterwards is positive, which means that f is decreasing and then increasing after 0. So we have a local min at 0, and at 1, 2, f prime capital F prime will be 0. So that means that that would be considered a critical number. Well, what's happening before f prime equals 0? So right here we have that f prime is positive, and then now it's negative. So that means so it's positive, then negative, so f will be increasing and then decreasing. So at 2 we're going to be having another local maximum. So let's just say maybe it's here. And we're just drawing a general sketch, so we don't know exactly where the max is going to be. All right, now, but at 1, x equals 1, we have another, this is where the second derivative would be 0. So there, and then we see that f prime is increasing, and then f prime is now decreasing. So we have it being concave up, and then it would be concave down. So therefore, at 1, there would be another inflection point, let's say maybe right about here. Sorry. And so what happens then is that just before 1, you see how f prime is increasing. So what that means is that, and so I'm talking about capital F prime. So capital F prime is increasing, so that means it would be concave up. As you see, it's concave up still here. Oops, sorry. So still concave up. And then right after 1, now the capital F prime is now decreasing, so that means the graph will be concave down. And then it's always decreasing after that. So continuing to be concave down. All right, and that would be the graph, or a graph, one graph for the antiderivative capital F of this function over here.